You just heard me mention quantum mechanics and relativity. Now this is where science gets very interesting, very addictive, and very strange. And for me personally, these two areas of physics are the most interesting, for they invoke lots of philosophy that go to answering our questions about the purpose of being. But this is a science lecture, so we have to leave the philosophy out of this. Now everything we see around us, all the galaxies, all the planets, and even each and every one of us, is made of atoms. So let's explore this further. Here's the periodic table of elements you may be familiar with from chemistry class at school. When this came about in the 1860s, scientists thought that the elements were made of indivisible spheres called atoms, meaning that they could not be broken down into smaller parts. As every element behaved differently, this meant that there would have to be a different type of atom for each element. In the 1890s, however, when J.J. Thomson discovered the electron, which was the first subatomic particle found, it was clear that atoms could no longer be thought of as indivisible, and that there were smaller things inside them. Just a decade or so later, Ernest Rutherford discovered the atomic nucleus, and concluded that the atom had the nucleus at the centre, with the electrons orbiting around it. Also, if all the mass was concentrated at the centre, then most of the atom, and indeed everything that makes up matter, including us, is empty space. So if my house was the atomic nucleus, then the electrons would be approximately a mile away across the border into Cheshire. Rutherford continued his experiments and discovered that the nucleus was made up of two smaller particles called nucleons, of which one was positively charged and the other electrically neutral. These were called protons and neutrons. Here's the first element from the table, which is hydrogen. The most important information here is the atomic number and the atomic mass. The atomic number tells us how many protons there are in the nucleus, and as all atoms are electrically neutral, then this also is the number of electrons in the atom. Now an atom may gain or lose electrons when undergoing a process called ionization, which results in a charged atom. Incidentally, if you ionize a gas, it becomes a plasma, something we touched on earlier. Now the atomic mass is an average of all the known isotopes of that element. Now an isotope is the same element with the addition or subtraction of neutrons in its nucleus. These are the same elements, but either heavier or lighter, and some are even radioactive. Fortunately, as the stable isotopes are the most abundant by miles, then all we have to do to calculate the number of neutrons is simply round the atomic mass to the nearest whole number and subtract the atomic number of the element. Simple.